This question gives us a system of equations, and our first task is to solve it using elimination of variables. So let's do that. So here's my system. I write it vertically. And maybe I will eliminate the y's. So I have 5 and 3. The common multiple would be 15. Make them both 15. This is positive 15. That's negative 15. So they'll cancel nicely. So doing the first one gives me 3 times 3x is 9x, plus 5 times 3y is 15y, equals 3 times negative 1 is negative 3. And doing the next one, 5 times 4x is 20x. 5 times negative 3y is negative 15y, and 5 times 6 is 30. So adding these together, what do we get? This subtracts out 9x and 20x is 29x. 30 subtract 3 is 27, dividing by 29. I get x is 27 over 29. Now you could plug that in to solve for y, but that's going to be very unpleasant. When you get a fraction answer, I suggest you eliminate again. So notice we eliminated the y's the first time. Let's eliminate the x's this time. 3x plus 5y is negative 1. 4x minus 3y is 6. 3 and 4 are the numbers. Their common multiple would be 12. Make them both 12, but make one of them negative. This is 4, this is 3. One of them could be negative. Fine, I'll make the second one negative. Distributing accordingly, do not forget to distribute to the right side. 4 times 3x, 4 times 5y, 4 times negative 1. 4 times 3x is 12x. Plus 4 times 5y is 20y, equals 4 times negative 1 is negative 4. Negative 3 times 4x, negative 3 times negative 3y, negative 3 times 6. Negative 3 times 4x is negative 12x, which is good because the x's disappear. Negative 3 times negative 3y is positive 9y. Negative 3 times 6 is negative 18. The x's go away. 20y and 9y is 29y. Negative 4 and negative 8 is negative 22. Divide by 29, and we have y is negative 22 over 29. So we think our answer is a point. What is the point? X value 27 over 29, y value negative 22 over 29. We hope that's the case. That was solving it by elimination. We eliminated both variables twice. Now it says use Desmos to graph both lines to find the point of intersection. Okay. That's going to get interesting. Notice we have fractions. Is Desmos going to enable us to handle those fractions? We will see. And what do we have? To Desmos we go. One of the equations is 3x plus 5y is negative 1. 3x plus 5y equals negative 1. And the other one is 4x minus 3y is 6. So the point of intersection is here, which is that 27 29ths, negative 22 29ths. Awfully hard to tell. But what I can do is I can graph that point. 27 over 29, comma, negative 22 over 29. And make that purple. Notice that seems to be the point of intersection. So that reinforces it a little bit. And then the last thing I asked you to do was to check it, right? We're going to plug that into the graphing calculator, plug 27 29ths in for x, plug negative 22 29ths in for y, and see if that's the case. So let's go to the graphing calculator. X was supposed to be 27 29ths, 27 divided by 29. Store in x, and then negative 22 over 29, store in alpha y, And then we're going to go ahead and look at our questions. Our questions were 3x plus 5y equals -1. Let's see if that's the case. Does 3x plus 5y equal -1? 3 alpha x or 3x plus 5 alpha y? Does that equal -1? It does, very good. And then the other equation was 4x minus 3y is 6. 4x minus 3 alpha y, is that 6? And the answer is yes, it is.